So in this video we will study some example how we can calculate the standard cell potential. For an example, for this reaction, which reaction at cathode, calculate the standard cell potential for the following electrochemical cells. This is one chemical cell is given here and another chemical cell is this one, and if you see that these two are written in the form of reduction potential. So basically here oxidation number is 0 for fluorine and here is -1. So it means it is showing that fluorine is accepting electron or gaining electron, and silver ion is also gaining the electron to going from plus to 0. So both are written in the reduction form. So how we will figure it out which reaction will occur at cathode and which reaction will become at anode. So here we have to pay attention on the E cell potential value. For fluorine is 2 plus 87 volt, and for silver you can see silver is here 0.80. So if you remember the previous video that where I said that how we can determine the electrode, so more positive value or bigger value will become cathode, and this will, and the reduction half reaction will happen on that one, and a smaller value or more negative value will become oxidation will happen on that in electrode, and that electrode will become anode. So we'll follow this rule to find out here. So this is more bigger value, so this is bigger value and it will become a cathode, and this is a smaller value, so this will become anode. So what we can do, we can write like this one, that F2 plus 2 electrons will become 2F minus, and E reduction potential is given. And for this silver ion, since anode oxidation will happen here, so I have to written silver solid is losing electron, becoming silver plus 1 electron. And if we are going to calculate the E cell potential for this reaction, so we will use this formula, that E cell standard reduction potential will be equal to E reduction potential plus E oxidation potential, right? So here E reduction potential is E reduction potential for the cell will be equal to for so here we have fluorine will become anode, and sorry, this will become cathode, reduction will happen on this one, and silver is oxidizing, so this will be oxidation and this will become anode. So E cell will become reduction means so this will become 2.87 and then plus. So here you can see this is 0.8, this is in positive value, but where if we have to write the oxidation reduction potential, we have to change the sign, 0.8. So basically we have to subtract from here. So the E cell for this example will be 2.07 volt, which will be in the positive. So this is the one example. Let's see in case of lithium and zinc. So lithium is here, which is the lowest value, and zinc have higher value. So this will become basically less negative or more negative, right? So this will become cathode and this will become anode. Here reduction will happen, here oxidation will happen. So this reaction basically it would work like this one, that zinc ion will take 2 electron, they will become zinc solid. So here this reaction will happen at cathode, and lithium will oxidize to lithium ion, and this will become anode. And if we have to calculate the E cell for this, so this will become E reduction potential plus E oxidation potential, and here this E cell will become negative 0.76, which is for zinc, then plus, then this is negative value, and this negative value will become plus. For oxidation, this will become 3.05, and once we will calculate, basically we are going to subtract from here to here, so E cell will become positive, again 2.29 volt. So this was the one example, two example how we can figure it out, and how we are going to calculate the E cell potential for this type of reaction. Let's take one more example here. So in this question they are saying that a galvanic cell is based on the reaction, this reaction, and half reactions are given, and give the balance cell reaction and calculate the E0 cell. So here I am not going to calculate the balance reaction, because I know that whether you multiply this reaction by 1 time or 10 time, or you do this reaction million time, E cell don't change. What we have to do here, we have to figure it out that how we are going to calculate E cell. So this will be E cell reduction potential, and will be equal to, and then plus E oxidation potential. How we will know that which one will be reduction and which one will be oxidation? So bigger value or more positive will be represent the reduction potential, and this reaction will occur at cathode, and lower value will become oxidation. This reaction will be oxidation, and at this chlorate will become our anode. This reaction will happen on the anode. So now we can calculate. So what we will do, 1.51 volt, and then plus, then both the values are positive, so here we have to change the sign for the oxidation potential, which is negative 1.19, and then once I will open, basically we have to subtract here 1.51 minus 1.19. So E cell potential for this reaction will be positive 0.32 volt. So this is the another example how we are going to calculate the E cell for reduction potential. And let's see one more example. Here we have this one, which I have already calculated here. So consider the galvanic cell based on the reactions. This is the reaction is given, and half cells are reaction given. So basically either two ways you can figure it out. Either you can calculate the oxidation number, and plus 3 is going to be 0. Basically it is accepting 3 electrons. So reduction, this is the reduction half reaction, and this is the magnesium is going from solid to magnesium ion, which is oxidation half reaction, and their values are given. So this is more negative, and this is less negative. So this is the bigger value or less negative value will become cathode. So this aluminum will become reduction cathode, and reduction reaction will happen. and this will become anode and oxidation reaction will happen. So now how we are going to calculate E cell? E cell will be E reduction plus E oxidation, negative 1.66 plus, then we have to change the sign of this magnesium from reduction to oxidation, plus 2.37 volt, and then once we will open the parenthesis, basically we have to subtract this 2 value and the E cell 0 will become plus 0.71 volt. So this was the another example. And let's see one more last example, number 4. So here we have these two reactions. Describe the completely the galvanic cell based on the following half reaction under standard condition. Silver reduction potential is given and iron reduction potential is given. Which one will become cathode, which one will become anode? Based on the values, the higher value or the bigger value reduction potential is for reduction potential, and this will become cathode. Lower value of E reduction will become anode, because oxidation reaction will happen on here. So again E cell will be equal to E reduction plus E oxidation. E reduction is 0.80 and then plus, then we have to change the sign of the oxidation for oxidation reaction or oxidation potential. So this will be minus 0.78 and then we have to subtract, so this will become 0.03 volt. So you can see in all 4 example, when we calculated the final E cell value, and everywhere we got the positive cell value. So if positive cell value we are getting, it means we added correctly, and that will represent that the reaction is going on spontaneous. So you can solve some more examples like this one to understand and how to calculate the cell potential.